In this video, I am going to solve the problems from the chapter 6 titled Force and Motion. Here, I am going to solve these 5 questions which is taken from the book Principle of Physics 10th edition. So let's we start the first question. The first question is given here. You have to read carefully. A 2.5 kilogram block is initially at rest on the horizontal surface. So you have to see the figure. This yellow color block is placed on the horizontal surface. A horizontal force F of magnitude 6 Newton and the vertical force P are then applied to the block. So here this horizontal force F which has the magnitude value of 6 Newton, and then we applied one vertical force. The coefficient of frictions for the block and the surface are static coefficient value mu s, which is equal to 0.4, and the kinetic coefficient mu k value is 0.25. Determine the magnitude of the frictional force acting on the block if the magnitude of P is 8 Newton, 10 Newton and 12 Newton. That means what we are going to do, we are going to consider a horizontal force F of 6 Newton, and then we are going to make our P force, that means the vertical force, with different value. The first one we are going to apply 8 Newton, and the second part I am going to apply 10 Newton, and I am going to apply third as 12 Newton. So here we have two coefficient value. The first one is the static coefficient value and the second one is kinetic coefficient. So what we have to do first of all, we have to draw the free body diagram for this figure. So first of all, I'm going to draw the diagram. So we place the horizontal block, that means we place the block on the horizontal surface, and then we have to draw the free body diagram. So what are the forces acting on this body? This body is initially at rest. So here we have the magnitude of F force, which is 6 Newton, and then we have a vertical force P, as well as we have the normal force. Am I right? So for that we have to choose a different color if possible. So here, what is our normal force? Our normal force here I mentioned with red color. So this is my normal force, and then the force due to gravity here is mg, and also we have the frictional force here. So we have to find what is this. Clear? So better I can write as ff, and then we are going to substitute the value, and first of all we have to frame the equation, then we have to apply the different vertical force P. Clear? So first of all I'm going to frame the equation. My upward forces, which is equal to downward forces. So here first of all I'm going to consider the vertical point of the vertical forces which is mentioned in the free body diagram. So what are the forces we have here? P plus Fn, which is normal force, which is equal to mg. So from this equation I'm going to find the normal force which is equal to mg minus P. So now what I'm going to do, I'm going to find what is the normal force, because we have all the values. So better first of all I am going to write what is given in the question. Magnitude of the force is given as 6 Newton, and then the mass of the block is mentioned here as 2.5 kilogram. What is the mass of the block? Which is 2.5 kilogram, and then static coefficient value is given, which is 0.40, and then kinetic friction value is given as 0.25, and then we have to apply the first force of the vertical P, which is equal to 8 Newton. So first of all I'm going to use this value, and then we have to find what is the value of the static friction and kinetic friction. So now I'm going to substitute the value for the So first of all, I'm going to consider 8 Newton for the P, and then we have the mass and the gravity. So Fn, which is equal to mass of the block is 2.5 kilogram multiplied by 9.8 minus of 8 Newton. So I'm going to work out with my calculator. 2.5 multiplied by 9.8 minus 8 Newton gives us 16.5 Newton. So what is my normal force? My normal force is 16.5 Newton. Now I have to find what is the maximum static coefficient value, and then I have to compare that static coefficient friction value with our applied force. So F static maximum, which is equal to static coefficient multiplied by normal force. Now we know the normal force. What is the value of the normal force? Just before we found as 16.5, and I'm going to find what is the value. What is the value of mu s? Here it is mentioned as 0.4 multiplied by 16.5 Newton, which gives us 0.4 multiply this gives us 6.6 Newton. Now what you have to do, you have to compare your static coefficient maximum value with your applied force. So what is our applied force? Horizontal 6 Newton. But what is our maximum static friction for this force, which is exactly 6.6? So what we studied in the theory, if our force will be smaller than the static coefficient, static friction force, the block will not move. Am I right? Because here we got the maximum static friction force as 6.6, but the applied force here is 6 Newton. So you have to compare your answer of the static friction as well as the applied force. So here our applied force is less than the static friction. So what will happen, my dear? The block will not move. So here the block will not move. Why? Because my static friction value is greater here. So we have to compare we have to go for the second value of the P, which is given in the question. What is our second value of the P force? Which is exactly 10 Newton. 10 Newton. Again, I'm going to deal with the formula. Which formula? F, which is equal to, that is nothing but our normal force. What is our normal force? Our normal force, which is equal to mass multiplied by gravity minus P. So here we got the value just before as 2.5 multiplied by 9.8 gives you it's a 24.5. So 24.5 minus 10 gives you 14.5. Am I right? So for this 14.5, let's we calculate the value of the static friction. What is the value of the static friction for this force? This force now it's 10 Newton. So we have to calculate what is the maximum static coefficient, so static friction, which is mu s Fn. Our mu s value is 0.4 multiplied by my Fn value is 14.5. Now we have to calculate the value of the friction. 0.4 multiplied by 14.5 gives me the answer of 5.8. What's the value? 5.8 Newton. Now you have to compare your value of the friction, maximum static friction, with our applied force. So you have to see here we applied 6 Newton, but what is the answer for this? We got 5.8. Now you have to say whether the block will move or not. Now the block will move. Why? Because my applied force is greater than the maximum static friction force. So the block will move now. The block will move now. Okay. Now for this, we have to find what is your kinetic friction, because once the block start moving, we have to find what is the kinetic friction for this value. What is the kinetic friction? We know the formula kinetic friction Fk, which is equal to mu k multiplied by Fn. So what is our Fn value? So here mu k value is given in the question as 0.25. Am I right? So you have to see here. So the mu k value is 0.25. So I'm going to apply the value here. 0.25 multiplied by what is our Fn force for this case? Our Fn force is exactly 14.5. Am I right? So 14.5, which gives the value of 0.25 multiplied by 14.5, which is 3.63. 3.63 Newton. This is our kinetic friction for the P force. Okay. And then we have to go for the third vertical force P. Our third vertical force P is 12 Newton. Am I right? So now we have to apply 12 Newton for this case. Again, we have to find what is the normal force for this, which is mg minus P. And here our mg value is 2.5 multiplied by 9.8 minus 12, which gives the value of 2.5 multiplied by 9.8 gives the value of 24.5 minus 12 gives 12.5. Am I right? So that is our normal force. Now we have to calculate what is our kinetic friction, because for sure your value will be greater if you just go for the static friction calculation. For sure your static friction will be smaller than the applied force of 6 Newton. So directly I'm just going for calculating. Better if you want you can calculate, no problem. So static maximum for this value is mu s Fn. So what is our mu f? Mu s, which is 0.4 multiplied by 12.5. So 0.4 multiplied by 12.4 gives the value of 5 Newton, but our applied force here is 6 Newton. You have to compare. So my applied force is 6 Newton, but the maximum static friction for this P vertical force is 12. We got 5 Newton. So now again the block, for sure the block will move. Am I right? The block will move. Am I right? So now once the block will move, again we have to calculate what is its respective kinetic friction. So Fk, which is equal to mu k Fn. So what is our mu k? Which is 0.25 multiplied by, for this normal force, 12.5 gives you 0.25 multiplied by 12.5 gives the value of 3.13. 3.13 Newton. Clear? So this is the answer for the first question. So you have to check for each perpendicular force of P. P vector is the perpendicular, that means the vertical force. So the concept from this chapter, the concept of this chapter is nothing but you have to compare your maximum static friction force with your applied force. If your applied force is greater than the static friction, then the block will move. If the applied force is less than the static friction, the block will not move. So we have a similar type of question in a different position. So by that you will get more idea. Understand? So when we just go for solving that question, by that you will get more information. So now we have to switch to the second question. What is our second question? This is your second question. A 3.5 kilogram block. So what is given here? The mass of the block is given as 3.5 kilogram, which is pushed along the horizontal floor by the force of magnitude 15 Newton. So how much force you are applying? You are applying the force of 15 Newton at an angle. What is the angle? The angle here is 40 degree with a horizontal, which is shown in the figure, as shown in the figure. So we apply the force F in this direction, and its respective angle here is 40 degree, and the coefficient of the kinetic friction between the block and the floor is 0.25. So you have to observe this this sentence here, brother. Actually here they directly give the value of the kinetic friction. There is no information about the static coefficient. Am I right? So if the static coefficient is not given directly, you can deal with kinetic friction. Clear? So this question has two subdivision. In the first question, we are going to find what is our frictional force on the block from the floor. Clear? So we are going to find the frictional force. When the block is moving, what should be the friction force between the block and the floor? We are going to find that. And then in the second part, we are going to find what is the block acceleration. That means the acceleration of the block we are going to find. So before that, what we have to do, we have to draw the free body diagram for this diagram. Okay, so I'm going to draw the free body diagram. So we place a block 3.5 kilogram on the horizontal surface, and then you applied the force in this direction. Am I right? So this is the resultant force. That means the force of magnitude we applied in this direction, and then based on the horizontal, its angle theta is mentioned here. Now we have to identify what are the other forces acting on this block. So better I can change the color. So by that it will be clearly understood for you. Clear? Okay. What are the other forces? If any body is placed on the horizontal, for sure the normal force will be there. So I have to write Fn, and also you have the force due to gravity mg. And apart from that, because this is your force, so you have two components. Am I right? What are the two component force you have? Near to the angle theta, your cosine force will be there, F cosine theta. And likewise, what is this? This is your F sine theta, and opposite to that you have the frictional force, that is kinetic friction. Am I right? So kinetic frictions you have. So these are all the forces acting on this block. So by using these forces, we are going to find the answer of frictional force, as well as we are going to find the answer of the block acceleration. So first of all, I'm going to find the value of the friction force, and for that we have to frame the equation by using this free body diagram. So my upward force, which is equal to downward force, because we need the normal force. Am I right? So first of all, I'm going to find the normal force, and for that better I can change the ink, the color of the pen. Okay. Okay. So how many forces in the upward direction? I have only one force in the upward direction, but two downward force. Am I right? So how I can write Fn, which is equal to F sine theta plus mg. Am I right? See, the left hand side is the upward force, and the downward side is the remaining two forces. So upward force, which is equal to downward force. Now what I'm going to do, I'm going to calculate what is my normal force. So F value, the magnitude of the force we applied here is 15 Newton of sine 40 degree plus the mass of the block here is 3.5 multiplied by 9.8. So let's see what is the answer. Just a minute, I will calculate. 15 sine of 40 degree plus 3.5 multiplied by 9.8 gives me 43.94. So the 43.94 Newton is my normal force. Clear? Now we have to calculate the kinetic friction, because there is no information about the static coefficient. Directly they give the value of the kinetic friction. So what I have to do, I have to find the kinetic friction directly. So what is our kinetic friction here? By using the normal force, as we already studied, the kinetic friction formula, which is exactly equal to the normal force multiplied by mu k. So here what is our normal force? 43.94 multiplied by what is our kinetic friction value, the coefficient of kinetic friction value, which is given here as 0.25. So that is our kinetic friction value, 0.25. So what is the answer? 43.94 multiplied by 0.25 gives 10.99. What is the value? 10.99, and the unit of the kinetic friction is this one. So this is the answer for the first part. Clear? Now in the second part, we have to find the value of the block acceleration. So better I will write here. So what is our acceleration? So you have to equate the right side force, which is equal to a left side force. So what is our rightward force here? F cosine theta, because in this direction the block will accelerate, and my rightward force, which is equal to leftward force. So how I can write, and which is equal to Newton's second law, ma, because all the times whenever you are going to deal with the acceleration, you have to equate the equation with Newton's second law. So here our equation here mentioned as F cosine theta, which is equal to Fk, which is equal to ma. Am I right? So how I can write F cosine theta minus my kinetic friction, which is equal to mass multiplied by acceleration. So now by rearranging these equations, we are going to find the acceleration of the block. So how you can rearrange? I'm going to keep this term here. I'm going to move only the mass. So therefore, my acceleration of the block, which is equal to F cosine theta minus Fk over the mass. Now substitute the value here. We have all the information in the question. So the force we applied here is exactly 15 Newton cosine of 40 degree minus our kinetic frictions just before we found as 10.99 over mass of the block they mentioned here as 3.5. Am I right? So now we have to find the answer for the acceleration. So 15 cosine of 40 degree minus 10.99 divided by 3.5 gives the value of 0.143. What's the answer? 0.143, and the unit of the acceleration is meter per second square. So this is the answer for the second part. So you have two parts in this question. First one, we have to find what is the kinetic friction, and the second one, we have to find what is the block acceleration. So you have to take practice. The most important thing, you have to draw the free body diagram, because all the equations we are just using here is based on the free body diagram. So if your free body diagram is perfect, the rest of the things will be easy. So now we have to go for the third question, and this question is exactly similar like your first question, but the only small difference is in the first question the block is exactly stay on the horizontal floor, but here the block is stay on the inclined plane. Clear? So you have to find the kinetic friction and as well as the static friction. So all these things we are going to deal in this experiment means, sorry, in this question. Clear? So let's read what is given in the question. In this figure, a force P act on a block weighing 45 Newton. So what is the weight of the block? The weight of the block they mention here as 45 Newton. And the block is initially at rest on the plane inclined at an angle theta, which is equal to 15 degrees. So what is the angle? 15 degree to the horizontal. The positive direction of the x-axis is up the plane. So you have to see here, up the plane. This is your upside of the plane. So this is your positive x direction. So it will be the negative x direction. Am I right? As they mentioned in the question, the positive direction of the x-axis is up the plane. So the coefficient of the kinetic, the coefficient of the friction between the block and the plane, or static coefficient mu s value here they mention as 0.50, and then the mu k value here as 0.34. In unit vector notation, what is the friction force acting on the block from the plane when P force is minus 5 Newton I cap, minus 8 Newton I cap, and minus 15 Newton I cap? So here the minus exactly tells you about the direction of the block acceleration. So here we no need to go for the negative value, because this shows the block is accelerating the negative of x direction, because this question is deal with one dimensional point of view. So what I am going to do, I am going to deal this P force, that means the P force magnitude. Okay, I'm going to work out all the three parts with the magnitude of the P vector. Why? Because this is one dimensional point of view, so no need to worry about this negative value. Clear? So first of all, we have to draw the free body diagram. We have a plane, and then we have the plane, inclined plane, and over this inclined plane we have the block, clear, and here we have P force, understand, and then we have to draw the rest of the, and then the angle theta they mentioned here, so we have to draw the rest of the forces. What are the forces acting here? First one, the normal force always perpendicular to the object, am I right? So this is your normal force, and exactly downward directions you have the force due to gravity, which is nothing but the weight, clear, and then exactly here you have W cosine theta, and here you have W's sine theta, and the same angle we have here, clear, always closer to the angle your cosine theta, and then opposite to the direction you have frictional force. So for the time being I am going to write FF. So FF here is nothing but what are the kinetic frictions we are going to find. So I will write like this, clear. Now for calculating the value of kinetic friction, we have to always go for the normal force calculation. So how you can calculate the normal force? The upward force, which is equal to downward force. So you have to consider this part, the upward force, which is equal to downward force, clear. So you should not consider the gravity, okay my dear. So here the normal force, which is exactly equal to W cosine theta. So first of all I have to find the normal force Fn, which is equal to W cosine theta, and here the W they mention as 45 Newton. So 45 multiplied by cosine of, what's the angle they mentioned in the question as 15 degree. So what should be the answer for this normal force? The normal force 45 cosine of 15 degree gives you 43.47, 43.47 Newton. So this is our normal force, clear. Now we have to calculate what is the maximum static friction. All the times whenever the static coefficient and the kinetic coefficient will be given in the question, first you have to deal with what is the maximum static friction. So Fs maximum, that means static friction maximum, which is equal to mu s normal force. So what is our mu s value, which is mentioned in the question as 0.5. Better we can just have a look. So 0.5 is the static coefficient value, so I have to deal with that value. So 0.5 multiplied by the normal force F 43.47. So 0.5 multiplied by 43.47 gives 21.74. 21.74 Newton. So this is our maximum static friction. So now you have to compare the force. So for example, you can see, you have to see the picture here. If the block will be if the block is moving in this direction, means that value should exceed this value, then only the block will move, am I right? So we are going to deal with a different value of the P forces. The P forces is given A, B, C, am I right? Just three parts you have. So first of all I have to frame the equation. My rightward force, that means this force, the friction force, which is exactly equal to the leftward force, the rightward force, which is equal to leftward force. And first of all I am going to deal with A value of the P. What is our A value of the P? So P value, I'm going to take only the magnitude. What is the first value of the P? Minus 5 Newton I cap they mentioned. Actually the first value of the P is, they mentioned, minus 5 Newton I cap. So I'm going to take only the magnitude. So what is the magnitude of this minus 5? Which is exactly 5 Newton. Clear? So for that I have to frame the equation of the friction force. So my frictional force, which is equal to, friction force means first of all we have to find what is the friction, which is equal to P force minus, so P force plus W sine theta. So this force which is equal to this force. Clear? So better I can write frictional force or static friction force. Let's check. So 5 plus 45 sine of 15 degree. What's the answer? 5 plus 45 sine of 15 degree gives 16.64 Newton. Now see brother, if you apply the P force as 5 Newton, we got 16.64, and here the maximum static friction is given as 21.74. Whether the block will move now or not, because we studied already in the theory, your force should be exceeding the static friction, then only the block will move. But here when we applied 5 Newton for this equation, we got only 16.64, but our maximum static friction will be 21.74. You have to compare which one is the greater. So here the maximum static friction value is the greater, so the block will not move. The block will not move here. Clear? So we have to go for the second part because you have three different P values. Am I right? So the second value I have to go P magnitude. They mention as 8 Newton. I will take only the magnitude value, which is nothing but 8 Newton. I'm going to again substitute the same equation, write the same equation, which is Fs, which is equal to magnitude of the P plus W sine theta. So here the magnitude of the P force is 8 Newton plus 45 sine theta. So sine theta here is 15 degree. So what should be the answer? Eight plus 45 sine of 15 degree gives you 19.64. What's the value? 19.64 Newton. Now you have to compare this value with the maximum static friction value. See here, the maximum static friction here is 21.74, but we got 19.64. This time also the block will not move. The block will not move. So we have to check with the third P force. What is our third P force? P, which is equal to 15 Newton, minus 15 Newton. So I am going to take only the magnitude. So better I can write 15 Newton here. Again, I have to deal with the same equation, the friction force, which is exactly equal to the magnitude of the P force plus W of sine theta. So this time my magnitude of the third P force is 15 Newton. So I'm going to substitute the value 15 Newton plus 45 sine of 15 degree, which gives us 15 plus 45 sine of 15 degree. So we got 26.64. 26.64 Newton. Now you have to see, brother, we got 26.64, but what is the maximum static friction? 21.74. That means this force is greater than the static friction. So now what will happen? This time the block will move. This time the block will move. The block will move now. Clear? So once the block will start moving, we have to calculate what is its respective kinetic friction. Clear? So what I am going to do, I am going to write the formula for the kinetic friction. Kinetic friction, which is equal to Fn mu k. So what is our normal force? As we already measured the normal force, what is our normal force? Our normal force here is 43.47. 43 43.47 multiplied by the mu k value they mentioned here as 0.34, I think so. So better I will check one more time. Yes, 0.34. So now I have to multiply 43.47 multiplied by 0.34 gives 14.78. 14.78 Newton. Clear? So this will be the answer. Understand? The most important thing, again and again I am just mentioning these things, all this calculation is based on our free body diagram, so you should take practice. Clear? Now we have to come for question number 21, I think so. This one is 21st question, so better I can write. Clear? 21st question. In the figure, a 15 kilogram sled is attached to a 2 kilogram sandbox. So see the picture here. We have two blocks. One is sled, which is kept on the horizontal surface, and another one is a sandbox, which is exactly hanging with the help of this the string, because they mentioned string. So you have to see, you have two blocks, one is sled, another one is sandbox. Anyhow, I will draw the diagram again because this diagram is not that much clear, so I have to draw the diagram again, and in that diagram I will mention how many forces acting. The free body diagram is very, very important. So first of all, we will complete the question. A 15 kilogram sled is attached to a 2 kilogram sandbox by a string of negligible mass. So the mass of the string we don't need to consider, wrapped over the pulley of negligible mass and friction. So here, no need to worry about the mass of this thread as well as the pulley friction. So we just avoid that. The coefficient of the kinetic friction between the sled and the tabletop is 0.040. So that means they give the value of mu k. What is the value of the mu k? 0.040. And the coefficient value is the unitless, so no need to write any unit here. Okay, and the first question, you have to find what is the acceleration of the sled. So we are going to find what should be the acceleration of the sled, and in the second question, what should be the tension of the spring. So two things you are going to find. What you are going to find in the first part? We are going to find the acceleration of the block. In the second part, we are going to find what should be the tension. Brother, you have to see the picture very clearly. If the block will be accelerate here, the same acceleration will be for the sandbox. At the same time, the tension applied to this string must be equal to the tension applied to this part. Clear? So that means it's very easy. When you just frame the equation properly, then the rest of the things will be perfect. So I will draw the diagram again, and in the diagram I will mention what are the forces acting on the object. So we have a horizontal tabletop, and here we have a pulley. So better I can just draw a pulley. Clear? And then here I can make a, because my diagram is not that much good. Okay, so here I have to place a sled. This is our sled. We'll draw the diagram one more time. So we have a tabletop, and we have a sled. This sled is connected by a string, and that string pass over the pulley, and then this side also we have the string, and here we attached a sandbox. Clear? So this is the diagram. So better I can draw string like this. Now I'm going to give the name. So this is our mass, the mass of the sled. I will write this is sled. This is our sandbox. Now we have to draw the free body diagram. So better I will use the red color. So here you have a normal force as we already studied. Normal force always perpendicular to the object when it is exactly kept on the horizontal surface. So this is my normal force. And then we have two masses. So better I can consider this mass of the sled is as m1. So what is the force due to gravity? The force due to gravity for the sled is m1 multiplied by g. And in the right side you have the string. So all the times the string will have a tension, and opposite to the tension you have a kinetic friction. Clear? And likewise, you have to draw the diagram, the free body diagram for this part. So here, this object is hanging by means of this string. So whenever the object is related with the string, there will be no normal force, only tension will be there. And here we have to consider this is our second mass. So I'm going to take M2G. So these are all the forces acting on these two objects. Clear? Now you have to see the two parts. One is the sled and the second one is the sandbox. In the sled, you have the vertical force as well as the horizontal force. What are the vertical force you have? Fn, which is equal to m1g. And what are the horizontal forces? Tension, which is equal to the friction force. Am I right? So because this object is having the acceleration this direction, and likewise here there is no horizontal forces because this object is exactly hanging. This is in the air. So there is no horizontal force. So if you see the picture, these are all the forces acting on this object. So by using the equation, because we are going to frame the equation by using the free body diagram, and from here we are going to calculate the acceleration of the block, the acceleration of the sled, and the tension produced in the string. So what I'm going to do, I'm going to frame the equation. So better I can write the equation here for the sled, and here I'm going to write the equation for the sandbox. What for x-axis, that means horizontal force I'm going to write, because the horizontal you have the acceleration. So this side, the block, the right side, the block will be accelerating. So the greater force here is tension. So tension minus the kinetic friction, which is equal to, because as I mentioned earlier, whenever the block will have the acceleration, you have to deal with the Newton's second law. Clear? So why I put tension here first? Because this side the block will be accelerating, so tension force will be greater, and opposite to the tension force you have the friction. So this is your horizontal force. What is your vertical forces for this sled? Fn, which is equal to m1 multiplied by g. Clear? So I'm going to give the name for this equation as equation 1 and equation 2. Clear? Likewise, I'm going to write the equation for this part, for the sandbox. There is no horizontal force, only the vertical force. What is our vertical force this time? Because this, if the sled will be accelerating to the rightward direction, the sandbox will accelerating due to the gravity in the downward direction. So which force is the greater? The second force, m2g, is the greater. So m2g minus tension, which is equal to Newton's second law. So I'm going to name this equation is our third equation. Clear? So okay, better I can use the Roman letter. So third equation. Clear? So now by using these three equations, we are going to find the answer for the acceleration as well as the tension. So for getting the value of the acceleration of the sled, what I'm going to do, I'm going to use the equation 1 as well as the equation third, because this equation has the value of the acceleration. See here we have the acceleration, also here we have the acceleration. So what I'm going to do, I'm going to add equation 1 and 3. So what is our equation 1? I'm going to add the left hand side with the left hand side, right hand side with the right hand side. So what are the left hand side here? This is my left hand side, this is my left hand side. So I'm going to add. So how you will add? It is a normal addition. tension minus the kinetic friction plus m2g minus t. So that means I added this part as well as this part, which is equal to, I have to add the right hand side. What is our right hand side? What is our right hand side? We have to add this one. Am I right? So here we have t minus this value. So we have to give the name because this is m1, this one is m2. Am I right? Otherwise both are same. So m1 multiplied by acceleration plus m2 multiplied by acceleration. So by using this equation, I'm going to find the acceleration. Why? Because this tension get cancelled with this negative tension, and here I'm going to take my acceleration as a common term. So m1 plus m2. And this side we have the kinetic friction, and we already studied the formula for the kinetic friction, Fk, which is equal to Fn. Am I right? Because Fk, which is equal to, what's the formula for the kinetic friction? Fk, which is equal to Fn mu k. What is the formula? Mu k. Fn multiplied by mu k. And what is our Fn? You have to see here. My Fn here is nothing but m1g. So in this place, what I'm going to do, m1g multiplied by mu k. So I'm going to use this formula. I'm going to use this equation here. So what will happen? Minus m1g mu k plus m2g, which is equal to a multiplied by m1 plus m2. So first of all, we have to find what are the things given here, because I did not write here everything. Only I just wrote the value of this mu k. So what are the other things give? The value of mass of the sled as well as the mass of the block. What is the mass of the sled? The mass of the sled here they mention as mass of the sled 15 kilogram. And what is the mass of the sandbox? Sandbox, I just sandbox as SB, which is equal to 2 kilogram. So, and then I'm going to substitute all this value here to find the value of the acceleration. So rearrange this equation. Therefore, the acceleration of the equation, which is equal to, so I can take the g as a common term here. Am I right? So if I took the g as a common term, m2 minus m1 g mu k over m1 plus m2. Now I'm going to substitute the value. What is the value? So here I should not write the g because I took the g as a common term, right? Substitute the value. What is the value of the g? Which is 9.8 multiplied by, what is the mass of the m2? Because m2 is the sandbox, which is 2 kilogram. 2 minus the sled mass is 15 kilogram. 15 multiplied by, and the mu k value they mentioned in the question as 0.040 divided by mass of the sled, which is 15, plus mass of the sandbox is 2 kilogram. Now you have to work out what should be the answer. Take your calculator. 9.8 multiplied by 2 minus 15 multiplied by 0.04, close the bracket, divide by 15 plus 2, 17, which gives the answer of 0.807. So what is the acceleration? 0.807. So better I can write the acceleration as 0.81 meter per second square. So this is the acceleration for the sled. Clear? So this is your part one. The first part answer is this. In the second part, we are going to find the tension. So here, for finding the tension is very easy, because here we have three equations: equation 1, equation 2, and equation 3. Am I right? So out of these three equations, which equations have the tension? We have two equations with tension value. Am I right? One is the first equation, and the second one is the third equation, because in the second equation there is no tension, so you can't use this equation. You cannot. It's not possible. So what I am going to do, if you want to use the first equation, you can go ahead. Or if you want to use the second equation, no problem. You will get the same answer. Clear? So what I'm going to do, either if you use the first one or third one, you will get the same answer. So what I'm going to do, I'm going to use the third equation for my calculation. So what is our third equation? Better I will calculate here. What is our third equation? Second part I'm going to find. M2G minus tension, which is equal to M2A. So I'm going to move this tension to the right hand side, by that it becomes positive, and I'm going to move this M2A to the left hand side, by that it becomes negative. Am I right? So what will be the equation? T, which is equal to M2G minus M2A. So here M2 is the common term, G minus A. So I'm going to substitute the value. Tension T, which is equal to the second mass. What is the sand mass? Sandbox mass. It is 2 kilogram, and G value is 9.8 minus acceleration. We have to take it from the first part, which is exactly 0.81. So I'm going to substitute this value here, 0.81. What should be the answer? 2 multiplied by 9.8 multiplied by 0.81. I got 15.87. Is it right? Tension M2, and here M2G we have to move here. By that M2 value is 2, I think so. 9.8 multiplied by 0.81. So I got the answer as 15.87. 2 multiplied by, once again I will check, 9.8 minus 0.81. No, sorry, 18.79 I got. Because if you should not, you got, sorry, you have to write the answer as 18.79 Newton. This is the answer. Clear? So now we have to answer the last question. Read the question carefully. 17.96. Sometimes I got 18. No, I got the answer as 17 point. Oh, sorry. 17.98. Clear? Okay. Now we have to solve the last question. And what is given in the last question? Read it very carefully, because this question is related with the circular motion. So we have to use our centripetal force. Circular motion, addict of mass 80 kilogram rides a Ferris wheel around in a vertical circle of radius 12 meter at a constant speed of 5.5 meter per second. So that means that the Ferris wheel is a circle wheel, and here the mass of the Ferris wheel is given as 80 kilogram. So you have three parts, three subdivisions. First of all, you have to find what is the period of the motion. In the second questions, you have to find what is the magnitude of the normal force on the addict from the seat. That means if the seat will be in the top of the Ferris wheel, what should be the normal force? In the bottom, what should be the normal force? So you have to find three answers. So first of all, we write what is given. We are going to write what are the things given in the question. Mass, which is equal to 80 kilogram, and then the radius of the circle is given as 12 meter, and then the speed here is mentioned as 5.5 meter per second. So better we can draw the diagram. Okay, so if you just see the Ferris wheel, it should be like a circle. So what is the question? If the object will be here, if the field, so if the person just will be here, you have to find what is the normal force. If it comes here, what is the normal force? So I have to change the color. So by that you will clearly understood what are the forces acting here. So all the times the normal force will be the perpendicular force. Am I right? So this is the normal force when when they are in the top of the circle. And here it's a circle. All the times the force due to gravity will be here. Am I right? So which is nothing but mg. And also you have to see the centripetal acceleration also this direction, right? Likewise, when the object comes to the down, your normal force will be this one, and your force due to gravity will be here, which is mg, and your centripetal acceleration will be towards the center. Am I right? So this is your center of the circle, which has the radius r. So this is your centripetal circle. So you have two cases. So now for this diagram, you have to frame the equations. Clear? So first of all, we will finish our first question. What is the answer for the first question? We have to find what is the time period. What is the formula for the time period? We have to use our basic formula for the speed. Speed, which is equal to distance over time. Am I right? So I'm going to use this equation here. So for the first part, I'm going to use this equation, and from that I'm going to find the time. Therefore, my time, which is equal to distance over speed. What is the distance? If the object want to make a complete circle, it covers the distance of 2 pi r. That is our distance. So I'm going to write in place of d, I'm going to write 2 pi r divided by our speed. What is our speed? Here they mention. So now I'm going to substitute the value. So what is the answer? T, time period T, which is equal to 2 multiplied by pi multiplied by the R value, that is the radius of the circle is mentioned as 12 divided by the speed is 5.5. So what's the answer? 2 multiplied by pi multiplied by 12 divided by 5.5 gives 13.70, 13.71, 13. 13.71 second. So now we have to find what is the magnitude of the normal force in the higher point as well as the magnitude of the normal force in the lower point. For that, we have to use the equation. So if you want to calculate the normal force in the higher point, what you have to do, you have to frame the equation. Upward force, which is equal to downward force. So what is our upward force here? B part. Fn, which is equal to mg, because mg here is downward direction, right? Clear? Because F1, which is equal to mg. And also we have the centripetal acceleration. We know the centripetal force, which is equal to mv square over r. So you have to compare this equation with this one. So if you want to move this side, what will happen? Fn minus mg, because my upward force for this is our upward force, am I right? Which is equal to our centripetal acceleration. So centripetal force mv square over r. Clear? So you have to equate this with our centripetal force. So by that, we can easily get the value of the normal force. So here in this equation, by that, if you just move this side, it becomes positive. Therefore, the normal force, which is equal to mv square over r plus mg. So we have all the data here. What is the mass? The mass here they mention as 80 kilogram. So 80 multiplied by the speed they mention as, I think 5.5 square over the R value is 12 plus 80 multiplied by 9.8. Clear? So I have to calculate what should be the value of the normal force when it is in the highest point. 80 multiplied by 5.5 square divided by 12 minus 80 multiplied by 9.8 gives the value of 582. The most important thing, I think here I just missed one thing, because the acceleration will be in the downward direction, so we have to put negative value here. Am I right? So this one is negative, this one is negative. So I got 582 Newton. If you want to write the value like this, 5.82 10 to the power of 2 Newton. So this is the answer for the normal force when it is in the highest point. Likewise, you have to calculate the same thing for this part. For the third part, I am going to use this forces Fn minus mg, which is equal to positive of centripetal, because here the centripetal acceleration is in the upward direction towards the positive direction. So I have to write mv square over r. Therefore Fn is equal to mv square over r plus mg. So this time we have to substitute the value. What is the mass of the object? 80 kilogram multiplied by the speed value, here they mention as 5.5 square divided by the radius is, I think the radius is 12 meter, plus 80 multiplied by 9.8. What's the answer? 80 multiplied by 5.5 square divided by 12 plus 80 multiplied by 9.8 gives the value of 985. 985 Newton. So you can write Fn as 9.85 multiplied by 10 to the power of 2 Newton. So this is the answer for the normal force when it comes to the lower point. So why here we put negative? What's the reason? Because if you see the first part, the centripetal acceleration is in the downward direction, so we have to use the formula mv square over r, but here the acceleration is in the negative direction. That's what I put negative. Clear? So initially I forgot to mention this negative, so here this is the answer for the B part, this will be the answer for the C part. Clear? So these are all the answer for this 5 question. That's it.